Hi, my name's Dan. This video is one in a series of videos that I'm doing to introduce the absolute basics of Blueprint visual scripting in Unreal. This series is designed for people who are complete newcomers to this and potentially have little or no programming background. In this one, I'm going to focus on the concepts of nodes and wires and try and explain what's going on in these script graphs. So the setup I've got here is I've got a third-person template map, and I have a blueprint that I created in the last video, which is just a simple walkable plates that you can stand on, and all I've done is I've replicated these to make a bridge across here. Now there was some little bits of scripting that we did in the last video. I've stripped some of that out, so I'm just going to show you where we're at with the script for this. And in fact, all I've got is a actor begin overlap. There we go, which will print a string and it'll just say the word on. I've disconnected the begin play and the to end overlap, and I've actually deleted the event tick. If you delete a node that was there, you can always get it back. So if I just right click on here, I can do event tick, and I can easily replace that if I want to. So I'm just going to click delete again. Right, let's zoom back out and let's just show this working. So I'm going to do a quick compile and go and play. There we go. And so I've got my bridge here, and hopefully this is going to be what you expect from that script. Is every time we overlap one of these bounding boxes that are there for these plates, the word on will appear at the top left. On. There we go. Several of them. And as we go back. So let's have a look at, I mean, that's just, a tiny, minimal script, really. But let's try and explain what's going on here, which is that when an actor, in fact, if you had things like bullets that were actors that were flying around the place, any of those would trigger this as well. It doesn't have to be the player character. But as soon as something overlaps, then it will print this string on. So this is the node that is the entry point to this script. So it's triggered by the event where that overlap happens on this particular script, and it'll trigger this node. And execution goes along the white wire. So this is a node, is a box, this is a node, and this is a wire. Okay, and as I mouse over that, you can see it's connected to these pins. These are called pins. And you might have done other visual scripting, but I'm trying to explain this for people who have never done any of this at all, if at all possible. So at any point in time whilst the program is running, you can say that there is a bit of code that is being executed, and the scripts that we have take their turn amongst that and get triggered. There's all sorts of other things that's going on as well in terms of rendering, but it's a little bit of a lie, but it happens one thing at a time, and so this takes its turn. When it's triggered, it'll make the script happen, and it'll follow the white wire along and print the string. So this is a function, which is this is a node that makes something happen. Is this function, the print string, and that's printing the string onto the screen. Now, if I want to do something else after it, triggered from the same thing, I can do that, because you see the print string has a right hand out exec arrow as well. I'm just going to do another print string here. I'm just going to have hello. So this will do on then hello. They'll appear in the opposite order. And we can make the script go as long as we like, as many pins out. So the events that are triggered only have an out pin, and you can see why, because that's a starting point to a script. Most of the, so all of the active nodes, and I'll talk about inactive nodes in a bit, all of the active nodes, I think, have an in and an out. There are a couple of exceptions when we get to functions, but we'll do that in a later video. Right, so let's just demonstrate that working. So both those things should be happening as we walk over. So on and hello. Now they always appear in reverse order because it stacks them with the most recent text on top. So as we go along, it does an alternating thing of ons and hellos, and we've fallen off. Right. Let's get back into the script. Okay, so let's have a look at these things. So these are sometimes called parameters, but they're basically that information that tell this print string node how to operate. And we've seen that in the one that's called inString, we can, it's got a box next to it, and we can type into that box what we want to be displayed on the screen. But you will see, I'm just moving that one out of the way, you will see that in fact there's a pin here, and you could put something into that pin. Now this is interesting because it's a pink wire, not a white wire. And I'm just gonna type in string. It's string literal. So make a literal string. Now this is actually not very different at the moment from the way that it operates if you just type into the box. We've got another thing here. We can type into a box. So I'm going to say boo. And I think I hope you can understand what's going to happen there. But there is something really important that I want to explain here, which is the line of execution goes down the white wires. Any other color wire is not about the line of execution. It's about data or about information. And you could think of it as being this node here pushes this data into this string here. I prefer to think of it as the other way around. I prefer to think of it that when this node is activated, it pulls the data in along any data wires that are connected to it. So this will ask this make literal string for the string that it's got, so that it can print it out. Yeah, go on, let's demonstrate it. We might as well. Hopefully we'll see there's a difference in here, and we'll have the boo coming up. Yes, hurrah. Okay, back into the script. So you'll see that it's pink, but you'll see that some of these other pins here are different colours. And so this here is a duration, and we can, as we mouse over, we can see it says it's a float. So duration, float, single position. Different types of data in Unreal. Different data in Unreal data has types. So as well as knowing what the value is, it knows what kind of thing it is. Now, if you've grown up by programming in Python, and a lot of people are these days, then this might be a new concept to you, the idea that information can have different types. This is actually really, really useful, although it's a good thing in Python that Python is what's called loosely typed, and so you can change the type of a variable kind of fast and loose, and it doesn't care. Grown-up programming languages that tend to be typed, and you might think that this is a restriction, and it is, but restrictions are good, because the more complex your program becomes, the harder it is going to be to find bugs. And anything that gives you sensible restrictions will help you not make bugs in the first place. If you talk to any, I'm on a bit of a rant here on a high horse, if you talk to any seasoned programmer, they will tell you that typed languages are better than untyped languages for large projects to help you not have bugs in your project. So, the upshot of this is that there are different types of data in Unreal, and this, as I mouse over the thing, is a string. Now, string means basically text. So if instead I look at the duration value and hold the mouse over here, then it tells me a float. That's a string. So a float is a kind of number which can have a decimal point. It's sometimes called a floating point number. And so this allows us, well, here we've got 2.0 in there. We could, again, we can put a literal, so make literal float if I want a different value in there. I could, again, this is a bit disingenuous because I could just type this into the box that's on the node, but let's make this 3, and it gives 3.0 seconds. I'm not going to demonstrate that. We've got red pins here and a dark blue pin here. So the dark blue pin will give us a colour. And if we want to try and spell colour in the American way, select colour, make colour. Can we do colour literal? Linear colour red, all sorts of literal colours here we can do. So that's just, it gives us a blue colour in there, for example. I'm going to get rid of that. I'm going to keep it as the light blue. These dark red ones, as you mouse over, they say Boolean. So that's a special kind of value that basically gives you one of two options, and is often called, often described as on or off, or true or false, or 0 or 1. And basically this is a yes/no kind of thing. So at the moment this is ticked, so this means it will print a screen, that means it's true. And this one's ticked as well. And again, I'll mouse off and say we can do Boolean literal, hopefully. Boolean. Make literal bool. So sometimes that's shortened to bool there, but as you see a mouse over there, it's Boolean, and it's named after a guy called Charles Boole, who invented a whole lot of maths around this. And again, all this does is it gives us the chance to tick it or not tick it, but we can feed in values from elsewhere into here. Okay, so I want to show that. I'm going to start taking these things off, and on actor begin overlap. So this output pin from here has got an actor reference, and this is also data, it's information, and it tells us this is a reference to the actor, so the in-game entity that has overlapped with this plate, with this blueprint. So we can get information out of that actor. So the only thing we've got moving around in the scene is the player character, which is a kind of actor. So it will be the player character, but it doesn't know that here in this node. And if I pull off here, well, any actor is a thing that has actors are things that have a presence in your game level. So any actor has to have a location. So what I'm going to do is I'm going to type in get actor location, and that's going to find out where in the world in 3D vector space, oh, scary words maybe, the actor is. And then I'm going to pull out from this. So this, when I mouse over this, this is a type that is a vector, and a vector is made up of 3 floating point numbers bound together, which gives us the X, Y, and Z location. But if I drag from I'm going from the yellow to the pink, which is the string. Interestingly, what's going to happen? It's well, as a mouse over, I haven't dropped it yet. It says convert vector to string, and there is a conversion available. So if there's a straightforward conversion available, it will automatically put that conversion in for us. So this node does a conversion. So what we've got now is we've got the execution node comes along, wire comes along here, makes this thing happen, and then this asks for the data, and it says, I want a string, and it's going back to this, it's going to convert something that's coming into it that's a vector. The vector is going to be from this passive node, get actor location. So these are both passive nodes in that they only work when something's being asked for. And then this takes the information that's being passed into the begin overlap. So we're going conversion from an actor type, finding the location with this node, getting into a vector type, and a conversion into a string type. Slightly complicated. Hopefully you're getting the idea, and I want to demonstrate that working. Coming up along here, and so it's now giving us, let's zoom in on the right hand side at the top as we run along. Slightly weird for me. It's giving us information about the location that the player character is at when he enters the bounding box, the overlap box for the play. Is that useful? Potentially not. However, it does demonstrate a kind of chain of things with data. We can do other things. We can combine bits of data and put them together. So I am going to do that. I'm going to actually move this around a bit. So all I'm doing to move is left-clicking on a node and dragging it as I go, and the wires rearrange themselves. What I want to do is to make this a little bit more informative. Actually, I'm going to take off that second print string. So I've just deleted that. And if I mouse over a wire and hold the Alt key and then press the left mouse button, it will delete that wire. Because what I want to do is I want you to say location at. I want to add some string to this. So I'm going to make a literal string. Literal just means you're giving it a value that is what you want to be used, rather than working out a value. And I'm going to say player at colon and a space, and then I'm going to use another node, which is actually it's a passive node, not an active node, but it does something useful. I'm going to use append, and this gives us a string append, and it can put another string on the end. So I'm combining these two strings. We can add pins, so I could add, I'm just going to put an exclamation mark at the end, why not? So that's going to put those three things in a row. I'm going to pull out from this data string data pin, pin and feed it into that. And again, I'm going to do a demonstration of this, hopefully, and it's got the player at, and then the position, and then the actual location. We're going to make this even weirder, because we're just going to have we're going to change this player at. No, I'll leave the player at. What I'm going to do is, instead of turning the vector into a string, I'm going to get rid of that. I'm going to break that vector into the three component float numbers. So if we break, it gives us the break vector 3f. So that node separates out the three different values. And I'm just going to take the z value, put that in, so that's the height. Again, it's done an automatic conversion, but this time from a floating point number to a string. These automatic conversions are really, really useful. So this, now it should only give us one value, which is the z value. In fact, it's the same because I'm walking along. If I jump in, you can hopefully see that it's a slightly different value going in there. All right. So that's a kind of a quick introduction to data pins and data wires. What I'm going to do is I'm going to just add a little bit more functionality to our plate, just to show you some more execution things. So what I'm going to do is actually, when we start playing, I'm going to make those platforms that we're walking on invisible to start off with. And so I'm going to drag off this. So this is event begin play, and this will happen for each of the platforms that are in there. And I'm going to do set visibility. And as I type that, it gives us me various options. And one of them is to set visibility of the cube. So the cube is the thing that you can see, and the box is the overlap, the thing that detects the overlap. So it's the cube that I want to change the visibility of. So I'll pick that one. And so it's automatically giving me some options for the components of the blueprint that I'm in. And getting that to do that as you want sometimes can be a little bit tricky, but in this case it seems to work quite well. And that's given us a node here which basically gets a reference to that component. We can do that ourselves by dragging off. And if I drag off there and let go, it'll give me a reference to that component. So this wants to know what thing you're setting visibility of, because you could be setting visibility of different bits within a blueprint, or things that are outside the blueprint if you've got some kind of connection to them. So this node, set visibility, needs 3 pieces of data. The first is which thing you're going to set the visibility of, and it'll see this is a static mesh component object reference. That's quite a mouthful. It basically means it's a reference to this thing that's inside our blueprint. So we know it's going to do the right thing. And the new visibility, this is one of these booleans. Do we want to be true or false? We want it to be false. So that's an empty box, means that it's going to disappear. So hopefully that means when we start playing, that all those platforms will become invisible, and that is correct. And what we want to do, I'm going to create this thing where if you walk along it, they become visible as you walk along, and then disappear again as you walk off them. So it's pretty simple, to be honest. We've already got an actor begin overlap, and I'm just going to add it on to the end of here. And I'm going to again do set visibility of the cube. It's automatically giving me the cube node there, the reference to the node, and set new visibility is true. So let's just zoom right in on that. So I've ticked that box to make it true. And then once again on actor end overlap, which I happen to have kicking around. Actually, this time I'm just going to show you. So this is to select more than one node, you can do a drag and drop. This is left click. To move around, I'm doing right click and holding and moving, and to zoom in and out, I'm using the scroll bar. So I'm just going to do Control C to copy those two, and then Control V, and it'll actually copy the wire with it. So anything that's connected with wires, if you're doing multiple selections, it will preserve the wires as well. And I'm going to plug that in, and that should make it invisible. Just do a quick compile, and then run. And it's been made invisible. We should still be getting the text. And as we walk along here, it makes the things visible and invisible. It's a bit like a kind of leap of faith thing. Just we happen to know it's there. So you jump up, you get out of that box, and it disappears, but you come down and it reappears. So what we can see here then is that we've got some quite short scripts, but I particularly wanted to focus on the difference between execution wires, what nodes are. So these boxes are all nodes, and they're connected together with wires, and data wires, and different types of data, which are different colors. Blue, this light blue means some kind of blueprint or component. So lots of different types of things can come along these blue wires. So I hope that's given you some understanding of the layout of scripts. Remember, execution goes left to right, so data gets pulled in. That's how I think of it, and or you could think of it as being fed in at the left and coming out at the right hand end as it goes through changes to the data to form the data that you actually want into the nodes that are going to use it. So that's it from me for now.